Okay, here we go. I'm going to run through the midterm, go through all 5 questions on the first 4 chapters and supplement A. So let's jump right in. Question 1 is about the Abco company that manufactures electrical assemblies. We're given some information there in the question, so this is just a simple multi-factor. I guess it asks for that. Multi-factor productivity calculation. You do it twice. So for the current process, we are going to have 200 units per hour times $20 for each unit, and we're going to divide that. So that's the output. We're going to divide it by the input. So the inputs are, we have the workers. So we have 10 workers at $10 an hour, and then we're going to add in our hourly materials cost, which we don't have to calculate because we're given as 120. And then we have to add in our overhead, which is 140% of labor. So labor, I'll just work it down here a little bit. So this is 4,000 over, and I'll just do 140% labor. So this is going to be 100 plus 120 plus 140. And that's just 1.4 times 100. So that's going to be equal to 4,000 over 360, and then I just plug that into the calculator and I got 11.1. So that's the multi-factor productivity for the current process. Now we also have to work it out for the new process, or the potential new process. So the new process, we're just going to do the same math. It's going to be 300 units times $20 a unit. That's the sale price given in the question. Our labor in this case is going to be 14 workers times our $10 an hour per worker. We're going to add in our cost per hour, which is given in the question, is $150 an hour. That's our material cost. And then we have to add it in again at 140% of labor. So it's 140, I'll do it this way, it's 1.4 times our cost of labor, which in this case is 140. So what we're going to have is 6,000, and this is dollars again, and we're going to have 140 plus 150 plus 14 times 14 is 196. So then that's going to be 6,000 over 486, right? And then I plug that into the calculator and I got 12.3. So at the end of the day, one of the things that becomes pretty evident is that the better process is the 12.3. So the answer to question C is yes, we should implement the new process. Okay, so question 2 deals with the preference matrix, and there's enough room in the table there, I would hope, that you could actually draw it in, and that's what I'm going to do here. We're told in the question that the weight of A is 40, the weight of B is 30, 20, and 10, nice and even numbers. And what we can do is we can take these numbers, and I just wrote them in the table, and that's perfect. If you did that in the midterm, that's perfectly acceptable. So we had 9 times 40, so this is going to be 360. 6 30s is 180, so on and so forth. So I'll just fill this table out now. Okay, so now that we have the table filled out, all you have to do is write the sum of each one of them down at the bottom. So I got 670, 680, 560, and 620. And once you've done that, all you have to do is pick which alternative is best, and that's going to be the one with the highest score, which in this case is 680. So alternative B should be done. I'll change the slide and switch to number 3. Okay, question 3. This is another one you could do simply by working it out, sort of writing it in the table. So all you had to do really was multiply these values here together. And this is about documenting your process, and you would have got these values here. Okay, so once you had the values, all you had to do was total them all up, And in the case of the existing method, I got 11,600,000 minutes used with the existing method. Moving on to the new method, if you move on to that, the total I got for that is actually 10,900,000 minutes. So to take those, see which were asked. What we're asked is just which is preferable. So the quick answer for that one is the preferable one is the one that takes less time, which is this 10,900,000 minutes. That's all that's required to answer the question. Change slides now on to question number 4. This is our process capability index. So there's a lot of information presented there. A couple things. We're going to have to work it out for each of the processes, the potential new machine that will have an average and the old one. So first I will do the old process. So a couple of things were given in the question. We're given x bar equals 99.97 for the existing process. We're given the sigma is 0.015. And we're given our upper and lower limits as 100.05 and 99.05. So our upper specification, so there's our specifications. So to calculate for the existing process, our process capability index, we're just going to take the minimum of 99.97 minus 99.95 over 3 times 0.015, and we're going to take 100.05 minus 99.97 over 3 times 0.015, and we're going to take the lower of those. So just plugging them into a calculator, I came out with the minimum of 0.44 and 1.77. So our process capability index for the existing process is 0.44. Okay, so now to move on to the other process, or the other machine is going to have an output. So it's going to hold exactly to target. So that's our 100. And the standard deviation for that machine is going to be 0.02. So we just do this exact same math this time. And one thing, without even looking at it, I can just see that because the target is being held, both of these calculations are going to work out to be the same. So when you work it out, you're going to find the minimum of 0.83 or 0.83. So our CPK, or our process capability index, is 0.83. This is for the new machine that can produce meter sticks exactly to target with a deviation, standard deviation of 0.02. Simply asked which machine will provide a better process capability index, and it's machine number 2, which has the higher value. Okay, we're on to the last question, question 5, which of course comes out of chapter 4, which is our capacity planning. We're given this chart that you can see here, and we're simply going to use this formula, which is basically going to do a bunch of calculations, and the numerator, of course, is how much time does it take to produce everything, and the denominator is how much resources we have to produce it, and that of course has to include our capacity cushion. I'll just start plugging numbers in here so we can work it all out. So our demand is 6,000 for the first job, and our process time is 0.8. Then we have to add in our 6,000 over our quantity per unit, which is 40, and our setup time per unit is 1. So this is our first job A. We have to add in then all of the other jobs. So this is the outputs, or the demand for all of the other jobs. So then it's going to be 4,000. Okay, so that's just basically copying all of the values out of the table, putting them in the right place. There's nothing more complex than that in the numerator. And in the denominator on the bottom, we're given in the question that we have 2,000 production hours available, and our capacity cushion is 10%. So what we want to do is take that 10% away from our total, Essentially what we're doing is taking 90% of 2000. So if we plug that in, we get, this will be 4950 plus 3030 plus 1300 all over 1800. And that gives a total value of 5.16 machines. As I mentioned in the example, you can't have 5.16 machines. You have to have these things in whole numbers. So the total is going to be 6 machines. So the correct answer is 6 machines. Okay, so that's it for the midterm. It shouldn't have taken you all the time. It was all mathematical based. I gave some good examples on video. So I'm looking forward to getting the tests in and getting them marked, and hopefully we'll have some discussion around it if you want.